Welcome to Brain Vision.
So given the constant c equaling 10 inverse nanometers, we know that a wave function will be proportional to e to the minus cl. And the transmission coefficient, being a probability, will then be proportional to the square of this. It'll be proportional to e to the minus 2cl. And tunneling current will also be proportional to the square of the wave function. So we can write that the current is proportional to the square. We only need to think about proportionalities because we're going to be taking a ratio. So we'll go ahead and write the ratio as the ratio at 0.5 nanometers to the current at 0.515 nanometers. And in this way, we don't have to worry about exact constants multiplying in the current equation. We only need to look at the exponential. So I'm going to write e to the minus 2 times c times 0.500 nanometers over e to the minus 2 times c times 0.515 nanometers. And then, of course, you just substitute in the value for c. So once again, this is in nanometers, and this is the value we have in inverse nanometers of c. This has the units of inverse nanometers. And we now have e to the minus 2 times 10 times 0.500 over e to the minus 2 times 10 times 0.515. And due to the properties of exponentials, you can also write this as e to the 2 times 10 times 0.015. And this will equal a ratio of 1.35.